Hello and welcome to my video. My name is Mr. Johnson and today's lesson is Inside Atoms, one of my 20 minutes lessons. And this is part of the GCSE Physics Radioactivity Unit. So without further ado, I'll share my screen and we'll get started. Today's lesson then is Inside Atoms. So what you should be able to do is recall the charges and the relative masses of the three different subatomic particles using symbols. In this case, you will need access to a periodic table. And finally, state what's meant by an isotope. This lesson is very similar in fact to lessons you would have taken in chemistry. It introduces a little bit of new terminology. First off, the mass of an atom is concentrated in its nucleus. The nucleus itself is made up of smaller particles, and these particles are called nucleons. It's a collective name for anything that's found in the nucleus. So nucleons can be a proton or a neutron. Collectively, they're both in the nucleus, they are a nucleon. All subatomic particles have very small masses. So instead of describing their mass in kilograms, which would be a really long and difficult number to process, we talk about what's called their relative masses. This means that we measure the mass of a subatomic particle relative to a different standard. We give the proton a mass of 1 atomic unit, and then we compare the mass of all of the subatomic particles to the proton. If you can imagine a pair of scales with a proton on one side, everything that we measure is then given a mass relative to how much of a proton it weighs. Here we have our atomic structure. So we've got our protons, our neutrons in the center, in the nucleus, and we've got electrons in orbit in the shells. This then gives rise to the particles. The subatomic particle, the proton, its location is in the nucleus and it has a relative charge of +1. It also has a relative mass of 1. That's our standard. Neutrons, they're also found in the nucleus. They have a relative charge of 0 compared to the proton. They have no charge. And they have a relative mass of 1. They have the same mass as a proton if placed side by side on a mass scale. Finally, there's the electron. Now, the electron's not found in the nucleus. It's not a nucleon, but it is around the nucleus in the shells. It has a relative charge of -1. It's the exact opposite charge of that found on a proton. And its mass is 1/1835. It's a small number that we deem to be negligible, but essentially it is the mass that is contained if I took one proton and cut it up into 1,835 pieces and took one piece. So, some questions that come around from this. Which two subatomic particles are nucleons? We've said that a nucleon is anything that's found in the nucleus. So at this point, we'd expect it to be just the proton and the neutron because their location in the table stayed as nucleus. Which two subatomic particles have a charge? Well, in this case, it's the proton with a relative charge of a +1 and the electron with a relative charge of -1. Finally, which two subatomic particles have a relative mass of 1? Well, in this case, that would be the proton and the neutron, because the electron has a mass that's so small, we consider it to be negligible or 0 at GCSE. Second question, what do these numbers tell you about the numbers of protons, neutrons, and electrons in the atoms of an element? This is almost a rehash of your chemistry, but it is important here as well because we're talking about atomic structure. So the atomic number is the number of protons, or the proton number, and it's almost always represented on your periodic table as the smaller of the two numbers in the atomic symbol. We'll get into that later. Finally, the mass number, that represents the number of protons and neutrons. All mass is located in the nucleus, so the mass number is the weight of the nucleus, which means it's made up of both protons and neutrons. For example, if I have a mass of 2 and a proton number of 1, then I must have a neutron number of 1 because 1 + 1 makes 2. So that's recall the charges and relative masses of the three subatomic particles, kind of a recap of what we've done in GCSE chemistry and how it relates to us in physics. Next bit, represent atoms using symbols. So here's an atom. GIF shows the nucleus, and around it, whizzing in the orbitals, the different electrons. All atoms of a particular element have the same number of protons. I like to say to my pupils, it's like the face on a person. If you have identical twins, they have identical faces. There are variations, of course, but for intents and purposes, the analogy suits. Identical twins look alike. Even if one got bigger and one got thinner, then they would still have the same face. You would still recognize them as twins. It's just one would be bigger in mass than the other. All atoms of a particular element have the same number of protons. The proton number is the face of the element. That number, the atomic or proton number, defines that element. Atoms of different elements then have different numbers of protons. So they have different atomic numbers. Hydrogen has a proton number of 1. If I talk about an element with a proton number of 2, I'm not talking about hydrogen anymore. I'm talking about helium. If I talk about an element with a proton number of 3, I'm no longer talking about hydrogen or helium. I'm talking about lithium. And if I was ever unsure, I can check the proton number of the element against the periodic table to see which element I am identifying. Neutrons have no charge, and so it's only the protons that give the nucleus its positive charge. Atoms have the same number of electrons as protons, and so atoms are always electrically neutral. They have no overall charge. Be careful of this. I'm telling you that atoms have no overall charge. Ions do. The number of neutrons then in an atom can vary. We've just talked about the analogy of twins, where they have identical faces, but one can have a heavier mass than the other. They're still the same twin. They still have the same DNA or instructions. It's just one's heavier than the other. The same is true of atoms of an element. The mass number or the nucleon number is the total number of protons and neutrons in the nucleus. So if the nucleon number is different for the same element, it's because it has more mass. Now we can represent the atomic number and mass number of an element in symbol form, as shown in the diagram below. Here I have an element, carbon 12-6. In symbol form, the mass number is pretty much always wrote above the atomic number in both value and position, but I don't like to state that that's the truth. I always like to think that if you are looking at the number, the smallest number is the atomic number or the proton number, and the largest number, because that is made up of both protons and neutrons, must be the mass number. They have tried to catch people out in exams before by writing them the other way around to see if you actually recognize which one's proton and neutron, and you haven't just learned by rote the position should be top and bottom. So be careful of that one. But the biggest number is made up of protons and neutrons. So in this, I have 6 protons. I have 12 protons and neutrons, which means that I must have 6 neutrons, because 6 plus 6 makes 12. Here's a periodic table of the elements. This is one taken directly from an exam paper from Pearson's EdXL. And if you look at it, you can see that it's quite clearly marked. Now, the nice thing about this, and the nice thing I think about any periodic table, is there's always a key. And it's worth looking at that key before you use your periodic table. What I mean is the box just next to beryllium, just under hydrogen, that says key. It tells you relative atomic mass, above atomic symbol, above name, above atomic or proton number. That's telling you the position of each one of those. Atomic or proton number is written on the bottom, so that number must be the bottom one. Above that is the name, so the name of the element is above the proton number. Atomic symbol is above the name, so above the name is the atomic symbol. Relative atomic mass is at the top of the box in the key, so the number at the top of each one of these elements is the atomic mass. If it tells you anything different, then use that key to identify which particular number represents what. So here, state the mass number and the atomic number of the following elements. Now, I do this in class, and it is as easy as it seems, but it's getting into practice the idea of recognizing which one's top, which one's bottom, which one's atomic, and which one is mass number. First off, for 1A, 11, 5B, well, 11's the highest number. In this convention, that would be the mass number. So the mass number is 11, atomic number is 5. 1b, 14, 7 nitrogen. We can see that the mass number is 14, the atomic number is 7. 1c, 42He, mass number 4, atomic number 2. 1d, 5927 cobalt, mass number 59, 27 for the atomic number. E, 5525 Mn, 55 is the mass number, 25 is the atomic number. And so we can see that this is what we would get going across. And then from that, we can work out the atomic number gives us the proton number, and the mass number, take away the atomic number, gives us the number of neutrons. So for question 2 here, for BE 11.5, I had 5 protons, 6 neutrons. For nitrogen 14.7, I had 7 protons, 7 neutrons, because 14 take away 7 is 14, and so on. Finally, the last question, look up the atomic numbers and mass numbers of the following elements in a copy of the periodic table. Represent each element in symbol form. It's essentially just asking you to draw or write the symbol. Lithium is 73Li, fluorine 199F, sulfur 3216S, krypton 8436Kr, calcium 4020Ca, iron 5626Fe, sodium 2311Na, iodine 12753I. You have to be able to use the periodic table. You get given one at the end of every chemistry exam, but any information that you need from the periodic table is not at the end of your physics paper. It will be within the question. So if you're asked something about this, be aware that there will be symbols on the page for you to use. Okay, that's representing atoms using symbols. Our last bit, state what is meant by an isotope in both words and symbols. So let's take a look. Now, 2 atoms of the same element will always have the same atomic number, but they can have different mass numbers if they contain different numbers of neutrons. In other words, I can have a heavier and a lighter version of the same element. Atoms of a single element that have different numbers of neutrons are called isotopes. This is carbon 14. Now, earlier we came across carbon 12. Carbon 12 had the symbol 12,6C. Because it's carbon, carbon 14 also has 6 protons. That's its atomic number. But now it has a mass number of 14. That means that the number of neutrons has increased from carbon 12 to carbon 14, but the number of protons remains the same. So carbon can occur naturally as 12, 13, or 14. The number in the name is the mass number of the isotope. The atomic number of carbon is 6. So an atom of carbon 14 or carbon 13 or even carbon 12 has 6 protons. But carbon 14 has 8 neutrons in its nucleus, because 8 plus 6 equals the mass number 14. Here we've got it represented in diagrams with some isotopes, one for carbon 12, one for carbon 13, one for carbon 14. You can see carbon 12 has 6 protons and 6 neutrons. This then means that the mass number is 6 plus 6 equals 12. Carbon 13 has 6 protons, but now it has 7 neutrons. It has 1 extra neutron, so it's heavier than carbon 12. That gives it a nuclear number of 6 plus 7, 13, hence the mass number 13. Carbon 14 has 6 protons and 8 neutrons. Again, it's 2 times heavier, so 2 neutrons heavier now than carbon 12, and so it has 6 and 8, which makes 14. Often asked question, define the term isotope using the picture above to help, and it's usually a 2-mark question on any exam, and the answer is quite straightforward really. The same proton or atomic number, but different mass or different neutron numbers. That is the standard definition. The atoms have the same proton or atomic number. If you say atoms of different elements, you've automatically got this wrong, because isotopes are the same element. They have the same atomic number. The only thing that's different is that some are lighter and some are heavier, so the mass number has changed because the neutron number has changed. So, as a dead simple example, some questions that we've got here. Atom A and B, as represented in the diagrams at the bottom of the page. First off, for atom A, number of protons. Well, we'd be counting up the number of positive charges because protons are positive. So as you can see from atom A, we have 1, 2, 3, 4, 5, 6 positive charges. Then for the number of neutrons, we've got 1, 2, 3, 4, 5, 6, 7 circles that are not positively marked in the nucleus. So the number of neutrons is 7. Because we have 6 protons, there has to be 6 electrons. We can count them, but we should know that anyway because we're talking about an atom and protons equals electrons in an atom because it's no overall charge, giving us 676. For atom B, the number of positive charges in the center, 1, 2, 3, 4, 5, 6, 7. The number of neutrons in the center, 1, 2, 3, 4, 5, 6. And the number of electrons, 1, 2, 3, 4, 5, 6, 7. So that would be represented here. What are the similarities between these two atoms? We can't mention the fact that they've got similar numbers of protons or neutrons or electrons, because that's not true. But actually, we can say they have the same mass, because the mass is made up of the number of protons and neutrons. Atom A has 6 protons and 7 neutrons, leading to a mass of 13. Atom B has 7 protons and 6 neutrons, which also equals a mass of 13. So they have the same mass number, or nucleon number, of 13. What are the differences between these two atoms? Well, they have different numbers of protons, different numbers of neutrons, different numbers of electrons. And because they have all of these, any of those would be perfectly acceptable as the answer. Are they isotopes? Explain your answer. Well, we've already said that isotopes are atoms of the same element with different mass numbers. And we can work out if the same element by looking at the proton number. If the proton number is the same, the element is the same. In this case, atoms A and B have different proton numbers, so they are not the same element. As a result, they cannot be isotopes. So the answer here is no, because they have different proton numbers, so they are different elements. Quick couple of examples. Again, a few more questions. The symbol for an isotope of beryllium 94Be. How many of the following particles does it contain? Protons and neutrons. Well, the proton number is 4, so it has 4 protons minus 4, so the neutrons are 5. A helium nucleus has 2 protons and 2 neutrons. Write down the symbol for the isotope of helium. Well, it has 2 protons and 2 neutrons, so the nucleon number is 4, that's its mass number. And the atomic number is 2, so it would be 4,2He. Finally, how many neutrons are there in a nucleus of an atom of oxygen 18? Well, it's not gave us an atomic number here, but the easy thing to do here is to go and look at a periodic table and find that actually oxygen has an atomic number of 8. So 8 away from 18 gives us our neutron number, which means there are 10 neutrons in oxygen 18. Carbon 13, we discussed it before, but even if we can't remember, we can look at the periodic table and find its atomic number is 6. Its mass number is 13. So 13 take away 6 even leaves us with a neutron number of 7. And this is what we find. So that's the last thing. State what's meant by an isotope in words and in symbols. Thank you for joining me this afternoon, and I hope that you've enjoyed this, and I hope to see you again next time. Take care. Bye-bye.